Okay, this is the first example for the chapter 5, section 5, equilibrium 3D for a rigid body. Okay, so the first step is to make the free body diagrams. In 3D, I found it a bit easier to draw directly on the picture. So I will use blue pen for non-forces, and here the only force that we know is that the force of 80 pounds is applied at the point D. That's the only force that we know. The force that we don't know, so we go around the pipe, and everywhere we have an external force, we need to determine what type of reaction. Is it forces on X, Y, and Z, or moment? It depends on the type of connection. So at B, we have a cable. So it means that the unknown forces, it's a tension that is aligned. Oops, it's a tension that is aligned with the direction of the cable. At A, we have a bearing, okay? The bearing, we are sure all the time that it prevents translation. So A X and A Z. The two translations that are not the translation of the shaft. So your shaft can move on Y, but not on X and on Z. And also this one prevents two moments. So when nothing is written, but it's written in your instructions. And it prevents also two moments. So which one? The rotation is free about the axis Y like this. Okay, the rotation is free, but not about Z and not about X. So let me draw them maybe in purple so you can see them a little bit better. Oops, Z. So moment about Z. That's the moment of A, Z. And for X, moment A, X. Okay, so your moment about A has two components on X and Z. I make them purple to see them correctly, but that's also unknown. Okay, I will show you two ways to solve this problem. Um, yes, yes. Let's, the first way is to look at the picture and think about which equation you can do first. So first, equation of equilibrium in 3D, what do we have? Okay, of equilibrium. We have 6 equations available. Equilibrium. We have sum of the forces on X is equal to 0. Sum of the forces on Y is equal to 0. Sum of the forces on Z is equal to 0. Sum of the moment about X is equal to 0, and we will use a point. In this case, the point that is easier to use is A. So we will use A, because that's where we have the more unknown. Sum of the moment about A on Y is equal to 0, and sum of the moment about A on Z is equal to 0. So let's look at which one, how many unknown we have per equation. X on X, so that's this axis. What do we have on X? The only thing that we have is AX. Okay, so with sum of the forces on X, it's equal to 0. Okay, let's just write that how many unknowns we have. It's one unknown is AX, so we can solve for AX with this equation. So we will do it first. Sum of the forces on Y, if we look at Y, how many equations do we have? How many unknown do we have? 0. So we will not use this equation. It's not useful. 0. How many unknown do we have? 1, 2, 3, 4, 5. Oh, we have 5. Okay. We have 5, so we need 5 equations. We hope we don't have one more equation that is 0 is equal to 0. On Z, we have AZ, TC that are unknown, so 2 unknown. MAX, that is this rotation, so we have this unknown, and we have TC also that create a rotation about X. So that's 2 unknown. Sometimes I change. Here we go. So that's 2 unknown. MAY. So about this axis Y, why do we have? There, we don't have any moment that we don't know about Y. And we have TC only. 1 unknown. Woohoo! We like that. And about Z, we have this unknown Z, and this equation, this TC, is parallel to Z, so it does not create any unknown, any moment about this, so one unknown. So now that we made that, we will decide which equation we do first, right? Okay, so let's do this one first, and this one second, this one third, and after that we will look at which unknown we have and which unknown we know now, and we will solve for the last one. Okay, sum of the forces on x equals 0. I say that we have ax is equal to 0. Okay, that's one answer. Now we say let's do sum of the moment a y is equal to 0. So what's create the moment about y? So we are at the point A. So no moment from AZ, no moment from AX, no moment, no MAX, no MAZ. So that's about this axis there. So we'll create a moment about y, and this is the positive direction for the moment. So we have this f time the distance of 1.5. Okay, that this 1.5 times this f. And if we are at y, we can see that is going in the negative direction, so minus. And this TC rotate in the plus directions, and so plus TC, and the distance from the axis y is 3. It's equal to 0. So we have minus 80 times 1.5 plus 3 times TC is equal to 0. So TC is equal to 80 times 1.5 divided by 3. So TC is equal to 40 pounds. So we found TC. Up. Now let's do the last one, MAZ. Sum of MAZ is equal to 0. And MAZ, we say that the only thing that we have is MAZ. It's equal to 0. Okay, so let's use this one. So no AX and no MAZ. And we found TC, we good with TC. So now we need to find AZ. And to find AZ, we can use the sum of the forces on Z. So that's a number 4 because now we know TC. So use sum of the force on Z, it's equal to 0. Okay, let me write 1, 2, 3, number 4. So we have AZ that is going in the plus directions, plus TC in the plus directions, and minus F is equal to 0. So AZ it's equal to, and I prefer to do AZ, but anyway, that's a Z. AZ is equal to, so F minus TC, TC and TC is 40, so minus 40. So AZ is equal to 40 pounds. Okay, that this one is AZ. So we got this one. And the last equation, so this one, number 5. Number 5, sum of the moment about the point A, but just about x. So sum number 5, sum of the moment about A on x is equal to 0. So what we have on x? So we have the reaction at A, so the moment A x, and this is different. Both of them are different. This one is the sum of all the moment about the point A at x, and this one is the reaction. And the reaction, the moment reaction inside the bearing is how much the bearing is able to prevent as a couple, like which couple the bearings can prevent. Okay, so MAX, so this one. And those creates moments. So we have F that creates the moment about X when we multiply by this distance. So minus 80 times 6. And this one create a positive moment, so plus 40, and at the same distance, that's 6 in this direction. So this and this one. Oops, this one is going down. 40 times 6, it's equal to 0. So MAX, it's equal to 80 times 6 minus 40 times 6. So it's 40 times 6. And it's equal to 40. That's in pounds. Pounds time feet. Sorry, I'm at the bottom of your. Here we go. 240 pound feet. So that's the first way to solve. It's relatively fast for 3D problems. The problem could be really long. You need to analyze the problems and look at which equation will solve for which unknown and how many unknown, and begin by the equation that is the easier to solve and go one equation at a time. I will do another video with the same problem, but another way to solve for it, and we will get the same answer, but it will be more like a recipe to solve 3D problem that I will show you. That works for any 3D problems. So see you in the next video. Bye bye.